Assalamualaikum. Hi again. So now we are looking at double integration over non-rectangular region. So if you recall, in my first video, I mentioned that if it's rectangular region, all the limits will be constant. Now let's look at our first equation there. Alright. When we are integrating, we will integrate starting with the innermost integral. That means with respect to y there. Okay. So look here. If that is with respect to y, that means those limits will be the limits of y. And we can see that there is x in the bracket, which shows that those limits will be in terms of x. And x is the outer variable for the outer integral. Okay. Now if we look at the second function, the second equation, yeah. Now we have x as the innermost integral. So let me just do a square bracket there. Oops. Alright. So that you bear in mind that we have to do the innermost integral first. So in this case, our innermost integral is with respect to x, and our limits can only be in terms of the outer variable, which is y. Alright. So, but please take note that the outer limit, the limits must always be constant values only. That bit. Yeah, it can only be constant values. Okay. So let's look at this example. Yeah, the limits are already given. If I ask you, what are the region of this? Is this a non-rectangular region or is it a rectangular region? Obviously, this is not a rectangular region. Why? Because of the limits there. You can see that is not everything is constant, so that means the region is non-rectangular. Okay, so let's solve this. As mentioned before, we have to solve starting with the innermost integral. That means with respect to y. So solving with respect to y, that means our x will be taken as constant. Okay, so that will be equals to the outer integral, which is between 0 to and dx. You still have to write that down. Okay, so let's solve x cubed plus 4y with respect to y. That means y is the variable, x is constant. So x power 3 is constant. Write it down again. So whenever you are integrating a constant, you add with one variable. In this case, our variable is y. Okay. Next, integrating 4y. So that will be 4y squared over 2. Alright. So our limits will be between x squared and 2x. Okay, so next step, we insert the values of 2x and x squared. Now, where do we insert that in? Do we insert that in x? Yeah, in x, or is it in y? So obviously, these limits are for y, so you insert that in y. Okay, so 0, 2 out there, you still have to write that down. Right, so inserting 2x. So x cubed is there, so times 2x plus 4 over 2, that's 2. So y squared, that's going to be 2x squared. That's inserting 2x. Okay, take away, inserting x squared now. So x cubed times y is x squared. Alright, plus 2, y is x squared squared. Okay. So the outer limit and integral of x must be written again. So between 0 to, so simplifying that, I will have 8x squared, take away x to the power 5, oops, of dx. Alright. So at this stage, I'm not expecting you to make mistakes. Yeah, this is single integration. So integrating 8x squared, that's going to be 8x cubed over 3, take away x to the power of 6 over 6 for the limits of 0 and 2. So as mentioned before, yeah, please write your steps. So just in case you have your final answer wrong, you can still get marks for method. So this is going to be 8 over 3, 2 to the power of 3 over 2 to the power of 6 over 6. Alright, take away 0, take away 0, and our final answer is 10 and 2/3. Okay, Let's do another example. All right. So this is an integration over non-rectangular region. So how do we know that? Because all the limits here are not constant, yeah, because we have that variable y there. Okay, let's integrate this. Now we first have to integrate starting with the innermost integral. That means with respect to x. Okay, so the outer integral, you have to write that down. All right, so integrating x sine y. So we are integrating with respect to x. That means our y will be taken as constant. So we have sine y there. That's a constant. So just write your sine y again. Okay, integrating x, so that's going to be x squared over 2 for the values of 0 up until cos y. Alright, so next bit, inserting the values, the limit, sorry. So we insert that into x values. So now it's going to be cos squared y over 2 times sine y. Alright, take away 0, so I don't have to write that down. Okay, so now let me bring this half out here. So half of cos squared y times sine y. So at this stage, you should recognize that we cannot integrate directly. We have to use method of integration. Now, what are the methods of integration that you have learned before? That would be substitution method. We have what else? We have by parts. We have tabular methods. Tabular methods are actually part of by parts. All right. So in this case, we are using substitution method. Means all y will be substituted with another variable. So let's say I take that as a variable u, new variable, yeah? So our cos y is going to be equals to u. All right. So if I put the next stage here, our cos y there, yeah, that's going to be u squared. So you want to substitute sine y dy. Where do you get that sine y dy from? So that would be from the differentiation of u. So du by dy, yeah, differentiating cos, that's minus sine y. Alright, so again, I repeat, we want sine y dy there. Okay, so rearranging our equation here. Now this becomes du equals to sine y dy, and I shift the negative to the other side. So our sine y dy is equals to minus du. So therefore, into our solution, cos squared y, that's going to be u squared. Sine y dy, that's going to be minus du. So negative out there, du. Now, can I put the limit here as 0 and pi? You can't do that. Why? Because 0 and pi are the values of y. Okay, so what you do here is just leave it as it is. Right? Do not try and find the limits, just leave as that and integrate. So u squared, integrate that with respect to u, that's going to be u cubed over 3. So next stage, you resubstitute. So 1 over 6 there. So now our u is going to be equals to cos cube y. Now you can insert the limits of 0 up until pi. So this is going to be equals to 1 over 6 cos cube of pi, take away cos cube of 0. Right? Cos 0 is equals to 1, cos pi is equals to minus 1. So that's 1 over 6 negative, that's minus 1, take away 1. Hence, our final answer is 1 over 3. Okay, now for the next part, we have the theorem for calculating the volume and area using double integration. So note here, you don't have to know how we derive this formula. All right, we're just going to apply. Yeah. Now using double integration, you can calculate the volume. Right, integrating over the region R, we have a function f inside there. Right. that means you are calculating the volume. If you have the function inside here as 1, yeah, integrating over the region R, that means you are calculating the area. Alright, so these formulas will not be given in the final exam or in the test. Yeah, you have to memorize this. Alright, so I repeat, calculating the volume, you will have a function f inside there, and if your function is 1, that means you are calculating the area. Okay, now in previous video you solved double integration but with given limits. Now let's say the limits are not given, so you have to find the limits. Yeah, now finding the limits is not a straightforward process. Yeah, there are a few steps here, so let's just go through the steps. Okay, so the first thing is you need to sketch the region. Yeah, you need to sketch the graph of the region. The region mentioned before was the region R. Yes. Next, you have to decide the order of integration. Now, the order of integration here means if you have your question in terms of y and x, so the order of integration, which means it's either dy dx or dx dy or dy dx. So you have to decide. All right. So our third step, we have to start with finding the outermost limit. All right. So the outermost limit will always be constant values, always. All right. You cannot have variables there. Okay. So our next step is we do guideline. Now this guideline will be parallel to the axis of the inner integral. So I would say here parallel to the axis of the variable of inner integral. So let me just write here as inner variable, yeah, to shorten things up. Okay, so last bit, we evaluate the integral. Okay, now let's say a function f is given throughout a region R. So first, as mentioned just now, we have to sketch the region. So let me just sketch here. Alright, so bear with me. So let's say we have a graph in xy axis, okay, on xy plane. Let's say I have a function g here. So this is curve g. Okay, so g in terms of xy, and I have a straight line there. Let's say this is of function h of xy. So where is the region R? The region R would be the region bounded by these two curves. Okay, so this is our region R. So the point of intersection, let's say, so the region is bounded at values of x between a and b, for example. So this is the value of x, and bounded on y at c and d, for example. Yeah, that's on y. So let's say that is your region R. All right. So if we want to evaluate the double integration, we have to decide the order of integration. So that's our next step. So let me just bring this down. Okay. So we want to find, alright, let's say our order of integration is dy dx. Alright. So we start off with finding the outermost limits. So note here, our outermost limits would be x. That means the limit here must be constant of x values. So look at the graph here. Our region R is between a and b. Alright. So make that as your outermost limit. So our outermost limit is between a and b. Now, for you to find your inner limit here, you construct a guideline. Now, the guideline must be parallel to the axis of the inner variable. So our inner variable here is y, correct? So therefore, that limit must be of limit y. Now, let's sketch guideline. So maybe I should choose a different color here. Okay, let's use that. All right. So look at that. The guideline states that it's parallel to the axis of the inner variable. So our inner variable here is y. All right. So guideline must be parallel to that. Parallel to the y-axis anywhere on the region. Just sketch one line. Okay. So the bottom bit here, that will be your lower limit, and that will be your upper limit. Now, if you look here, our lower limit, yeah, that is on that curve. Yeah, so that curve is our function g. So let me just put here. So our lower limit is of function g. Right? And our upper limit here, that is on that straight line. So that straight line is of function h. Okay, so let me just put here. So that's the function h for your upper limit. Right, let me just put some notes here. Our guideline, okay, our guideline must be parallel to y-axis. Okay, now next step, of course, we will evaluate. Yeah, now let's say we are doing for the other way around, dx dy. Okay, so now our outer limit, that will be y. Yeah, so looking at the figure here, all right, on the y-axis, the graph starts, the region starts from C going up until D. So therefore, our limit of outer limit, that will be between C and D. Okay, so for the inner limit, so just as before, let me just write it here. The next step is you want to sketch a guideline, and the guideline is now parallel to the inner limit, which is parallel to x-axis. Where is our inner limit? Okay, that is our inner limit. That's why it's parallel to x-axis. Okay, so guideline parallel to x-axis. So anywhere in this region, you sketch a guideline parallel to x-axis. There. Okay, so where it starts, that is going to be your lower limit. Where it ends, that is going to be the upper limit. So if we look here, yeah, our lower limit there, that is on the straight line. Okay, the straight line is h. So let me just put here, our lower limit is h. Okay, so our upper limit there, that is on that curve, which is function g. There. Okay, so one thing we have to bear in mind, what we are going to put as our limits cannot be the whole function. All right, so just note here, okay, for function g here, yeah, note that we are finding, yeah, so I'm referring to this bit, yeah, we are finding the limits of y. So you have put between g and h. So we have to rearrange here so that g will be in terms of x. All right, and h we have to rearrange also, that will be in terms of x. Okay, now I will explain using the example below. Okay, now the question given, x cubed plus 4y. Okay, so if you look here, the limits are not given, but it's stated that it's bounded by the parabola y equals to x squared and y equals to 2x. So the first step is you have to sketch the graph. Okay, so let's sketch this. Let's change back the color. All right, so that's going to be our y-axis. That's too long. So the graph is bounded by the parabola y equals to x squared. So the graph of x squared, y equals to x squared is something like that. Oops. Let me do that again. Okay. So this is the graph of y equals to x squared. All right. And the other line is, okay, y equals to 2x. So the graph of y equals to 2x is a straight line passing through the origin. There. So let me just write it here. So this is y equals to 2x. So where is our R region? Our R region is the region bounded by these two lines. Okay. So this is not complete. You have to find the point of intersection. Now, the point of intersection will be on x-axis there, and this is on y-axis. Okay, how do you find the point of intersection? Obviously, it's between the intersection between those two lines. All right, so let me just do some calculation here. So y equals to x squared, that is going to be equals to y equals to 2x. We can just write it as such. All right, so x squared take away 2x equals to 0. Okay, so I'm bringing the x out, factorizing out, so that's x minus 2. Hence, I have 2 points of intersection. The first one is x equals to 0. The second one is at x equals to 2. So our values of x, that will be 0 there and 2 there on x. Alright, so you need the values on y as well. So if x is equals to 2 here, alright, the values of y would be, you can insert x value into any of the equation, either that function or that function. So the value of y is going to be equals to 4. So this is our first step. We have sketched the region. Okay, second step, we want to evaluate this. Yeah, this is what you want to evaluate. Let me just bring this up. Okay, so our question is, integrate x cubed plus 4y dA over the region R. Alright, so now you have to decide the order of integration. Okay, so let's say I decide on dy dx, the same function, x cubed plus 4y. Okay, how do we start the order, the limits? We always start with finding the outermost limit. So what is the outermost limit? That will be the limits of x. So look at the figure there, yeah, the graph. On the x-axis, the region R starts from 0 going up until 2. So that will be your outer limit. So from 0 up until 2. Alright. So for the inner limit now, you have to sketch a guideline. Okay, now the guideline is parallel to the y-axis. Okay, so anywhere on the region, you sketch a guideline parallel to y-axis. There. So that will be your lower limit, and up there will be your upper limit. Okay, so our lower limit, which is there, is on this curve, which is y equals to x squared. So this is a tricky part. Yeah. So y equals to x squared is going to be our lower limit, but you cannot put a function inside there. All right. So what we want to find is the values for y. So since y equals to x squared, that means what we need to put there is only x squared. All right. So I'm going to take this off. Okay. I'm just going to put there as x squared. All right. Now for the upper limit, okay, which is that bit, that is on the straight line. The straight line is y equals to 2x. So what we want on the upper limit is y equals to 2x. But again, we don't put everything inside there. You check. What we want is the values for y. So y equals to 2x, that is your upper limit. Alright, so let me just take that off again. Okay, so what is at the top here? That would be 2x. Right? So once you have your limits ready, then only you integrate. Now, if you recall, we have already solved this, right, in our previous video. So I can just swipe this down. Okay, there. We have already solved that. Okay, and our value is 10 2/3. Okay, so let me just put the answer there. Alright, so this is going to be equals to 10 2/3. Okay, now if I do not want to choose the order of integration as dy dx, I can use dx dy. Okay, so let's say, let me check. Alright, so now the same equation, but we want to change the order of integration. Okay, so the same question, x cubed plus 4y, but now the order of integration is dx dy. Okay, so you will use the same figure, yeah, the same graph here. Just bring that down a bit. Okay, how do you start finding the limits of integration? Just as before, we will find the outermost limit first. So the outermost limit is with respect to y. So looking at our region R here, on the y-axis, the region R starts from 0 going up until 4. So that is going to be your outer limit. Alright, so that is between 0 and 4. Okay, now for the inner limit, we use a guideline. And the guideline must be parallel to the x-axis. Okay, so on the same figure, now we sketch anywhere in the region, okay, parallel to the x-axis. Let's say there. So that's going to be your lower limit, and that's going to be your upper limit. Now, this is where the tricky part is, yeah? So where is the lower limit? The lower limit is on this straight line. That's your lower limit, so that's on the straight line, yeah? Y equals to 2x. So let me just put here for a moment. So our lower limit is going to be y equals to 2x. But check again, what are we finding here? We are finding, okay, we are finding the values of x. That means we want to rearrange this so that it's x in terms of something. Alright, so let me just do this at the side here. Let's use a different color. Okay, so for this one, so we want to change, yeah, y equals to 2x. Yeah, since it's in terms of x, we are finding limits of x, so change that. X equals to y over 2. So this is going to be your lower limit. So let me take this off. Okay, so now our lower limit of x is y over 2. Okay, now let's do for our upper limit. So let's go back to our figure here. Our upper limit is that bit which is at that curve, y equals to x squared. Okay, so let's go back to our equation here. Okay, so our upper limit is going to be y equals to x squared, but you cannot put everything in there. Alright, so let us do that over here. Alright, so we have upper limit y equals to x squared, but we are finding the values of x, so you have to rearrange that equation. So now x equals to set of y. Okay, so what you put as your upper limit here, right? So that would be set of y. Okay, So let us solve this and see whether we will get the same answer. Right, let me just do this. So equals to, we are integrating with respect to x first, yeah? We start with the innermost integral. So integrate 0, 4 and dy, you have to write that down. So now integrating x cubed, integrating with respect to x, so x is our independent variable, so that's going to be x power 4 over 4, okay, plus 4y, y is taken as constant here, so write that down again and add 1x, right? So the limits would be between y over 2, our upper limit is y to the power of half, yeah, I'm changing that, y to the power of half. So our next bit, we insert the values of, we insert the limits for x. Now where do we insert the limits? Is it in x or in y? So it should be in x, right? So now that's going to be y to the power of half to the power of 4 over 4 plus 4y, okay, and here I have y to the power of half, alright, okay, take away with y over 2 to the power of half over 4 plus 4y times y over 2, alright, integrate with respect to y. Okay, so next, alright, so that's a bit tedious there, so I'm going to just bring it down here. Okay, so that will be equals to, yeah, simplifying. So now between 0 and 4, simplifying the function inside there, that's going to be y squared over 4 plus 4 y to the power of 3 over 2, take away y to the power of 4 over 64 minus 2y squared dy. Okay, so integrate that. Now please do that as an exercise. You will get the answer the same as before, which is 10 and 2/3. Okay, so we'll stop now and continue with finding the area and volume using double integration.